So, good morning and welcome to today's webinar on ISO 16890, the Global Air Filtration Standard. My name is Markus Ladner. I'm the Managing Director of Eurovent Middle East and also the International Director of Eurovent. Let me see if that works with the webcams. Yes. For those of you who are not aware yet of Eurovent, Eurovent is the largest European industry association for heating, ventilation, air conditioning, and refrigeration. Eurovent Middle East is an independent offspring for the wider Middle East region. And Eurovent Certita certification is our equally independent certification organization, which is best known for its Eurovent certified performance mark for certified and proven equipment. We are happy to have support for this webinar today from our knowledge partners. This is REBA, the Federation of European Heating, Ventilation and Air Conditioning Associations, from ISHRE Institute of Excellence, and also from the ISHRE Daily Chapter. We also like to appreciate the support of our media partner, Climate Control Middle East, who is providing editorial cover for this webinar. And before we get started, I would like to inform you about a few technicalities. First of all, you're all muted in order to not interfere with the presentations. However, you can interact with us in the way that you can ask us questions, which you can type into the control panel in front of you. Should you wish to leave the webinar, please just close the control panel and you will have a menu option provided to get out of it. I also would like to draw your attention to the handouts which we have available today, which you can also download directly from the control panel. These are, first of all, the Eurovent Air Filters Guidebook and the Eurovent Recommendation 423, selection of E and ISO 16890 rated air filter classes for general ventilation applications, a document which we will hear more within this webinar. The agenda for today, after the introduction, we will hear from PK Göll about the global air filtration standard in general, followed by the guidance to the application of this standard, then a section on energy efficiency and air filter certification, at last a summary of the key takeaways of this webinar, and we will close with a panel discussion in the end, including a question and answer session. So please be with us until the end of the webinar with your questions. We will try to answer as much as possible within this event. Our speakers today are PK Göll, Technical and Industry Advisor from Eurovent Certita Certification and lecturer at the ISHRE Institute of Excellence. Mark Schmidt, Vice President Technologies Europe from American Air Filters and Chairman of the Eurovent Product Group Air Filters. Sylvain Coté, Technical Director of Eurovent Certita Certification. And last but not least, Banjaj Kaul. He is a country representative in India for Eurovent Certita Certification and a well-known public policy professional. Also with us should be today a guest panelist, Ilinka Nastase, Associate Professor and Director of the Doctorate School of the Technical University for Civil Engineering in Bucharest, and also the Co-Chair of Technology and Research Committee of REBA. REBA has provided us as well with 3 additional handouts which you can download from the control panel. This is once the REBA COVID-19 guidance in its version 4.1, the latest version. Highly recommended read. We also have available an article about room air cleaners and information about an online education program, the safe operation of buildings in HVAC systems during the COVID-19 pandemic. Let me briefly check if Ilinka is already with us. No, so then we can continue. I would like to call PK. Good morning, PK.
Good morning, Marcus.
I will hand over to you in a second, and it's all yours now.
Thank you, Marcus. First of all, thank you for having us on the program. It's a great honor to be on this kind of a program with stalwarts in air conditioning and mainly in filters, Mark Schmidt and Silva, and all of you, and our greetings from India to start with, to all the 387 attendees that we see now on the screen. And also a very warm welcome to the participants from Middle East. As you know, I have spent 25 years in the Middle East before coming back home. And I have many friends today listening on this program, and my greetings to all of them. So I will be presenting basically the designer's perspective. And just to tell you that we are now building our country. That means there are more new jobs that are coming up in India than probably a lot of the regions that are listening into this presentation today. And it's very important that we get it right. And a lot of development will take place in the field of healthcare, where air filtration is going to be a very key thing. And it's also going to be key going forward as the offices reopen. At the same time, there is a big push in India for energy efficiency. As you know, we are a part of the Paris Agreement, and we are very focused. And so we have so far contributed a lot to it, and we would not like to lose the lead that we have set up in terms of energy efficiency. So the first thing that came to me on this particular topic was, are basically energy efficiency and indoor air quality mutually exclusive? And they are not. And after having researched in detail all the good handouts that Eurovent has provided, I could say with firmness that energy efficiency and indoor air quality also go hand in hand, and they are not mutually exclusive. So let me move forward to the slides, and let us first understand some basics of what 16890 2016 is all about. And in fact, today, this will be left to the participants, whether we could deliver it properly, whether at the end of the day it was taken home or not. We will put in all the efforts that are necessary to make the ISO 16890 the specification or the standard on filters going ahead. A little bit of historical perspective. So in India, we did have a standard some time back, and during my research, I did find out that the first person that I worked under 40 years back was probably the head of that standard. And have we got revisions? My research does not show that at this point of time. But I'm fortunate to say that the National Clean Air Program people in India are listening into this particular webinar today. And going forward, we would also be able to put in the standard as we have put in for indoor air quality, as we have put in for chillers, air handling units, so that we can keep track of the energy efficiency. So many a years back, basically, indoor air quality was related with sick building syndrome, and we worked a lot on it, basically. And then in the year 1987, EPA came in and defined the particles in terms of microns or sizes. PM1, PM2.5, and PM10 was first heard about. So where was all this coming from? Because before that, we had something like coir filters and metallic filters that wouldn't take care of these small particles. And these small particles were becoming important as the time proceeded. So it was coming basically from burning of tires, from brake shoes in cars, lead in petrol, a lot of fine particles. And this PM1, PM2.5 was sort of becoming an area of concern as time proceeded. At that point of time, ASHRAE 52 and EN 772 became the initial standards with, and the testing on that was with a single grade of dust. So once the gradation was done, there was a need for a change, and the working group 3 of the ISO TC 142 was called into action, and it devised a very detailed method of testing, and you will hear more about it from the experts in this program today. So going ahead, what did PM1, PM2.5, and PM10 do? It affected the different parts of the bodies. The PM1 reaches deep inside the lungs, the PM2.5 to the middle lobe, and the PM10, of course, affects your throat, etc. But all these things have an effect on the human body, and the WHO realized the importance of these particles, and any filtration standard that comes in must basically revolve around these particular nomenclature of PM1, PM2.5, and PM10, because it becomes easy for designers like us to understand amongst all the other things that designers do to get their air conditioning HVAC systems right. I want to say there's lots of chill water and DX and what have we. And then when it comes to filters, one very important thing is that it should not basically be very complex. It should be something which is understood by the designing fraternity. There are times when we need to bring in experts, and they are available. But there are a lot of projects that are done in India where, you know, basically the designer has to pitch in at any point in time, and the standard should be understandable by everyone. And that's what we saw in ISO 16890. And that's the reason I would say that this should be the standard going ahead. Okay, so recently, when we see air handling unit submittals, we find these terms EPM10s, 50%, 60%, EPM1, 60%, and other things appearing on the air handling unit submittals. We did a small or a reasonably good presentation on hygienic AHUs, and we found that we got many questions from the listeners asking us to go into the details of this particular nomenclature. And that is what I think we are here principally to do today. A lot of experts will contribute into it, but this is a nomenclature that makes the designer's life easy, because through this we get to know which particle size to what efficiency is being removed, and you have a gradation. So going into the details, the part E comes from treated and untreated filters conditioning with IPA streams, which has changed from EN 772. So you will hear the experts talk about it. And going ahead to the next slide. Yeah, let me go back one, sorry for that. So when we hear about the MERV or the ASHRAE 52 filter process, the difference was that this did not have that particular gradation, which comes into IS 16890. And as I understand from my reading up things, that ASHRAE is also in the process of modifications based on this particle size. Going ahead, this is a graph that we all need to understand. The blue line, which is showing on the left-hand side picture, is basically the distribution of the PM particles as we see in the atmosphere. And this has been peer reviewed several times, and it has been widely discussed. And what we need inside the hatched area is what we need in our supply air, the PM levels, in order to meet the criteria in spaces. Some of the countries like India going ahead in the ISHRE IIQ standard, we have clearly defined the PM 2.5 and PM 10 levels in microgram per meter cube of air. And we would like to see levels below this in order to classify a building as Class A, Class B, and Class C. Now, very easily, meters like this are available all across. And it's pretty simple for consulting engineers and professionals to go around now in the buildings to see what is the kind of IAQ standards that they are finally getting. So we are again talking about the particle size PM1, PM 2.5, and PM10. And with the help of all the guidelines that we see that are now provided by Eurovent, it becomes easy to understand the difference between EN 779 and ISO 16890 and increase the awareness on the energy efficiency of air filters. I was very happy to see that a lot of work has been done to talk about the energy efficiency of air filters, because many systems do not take this into account. So basically, what is happening is that at Eurovent certification, they have been able to grade the filters depending on the kilowatt hour that a filter consumes working for one complete year. And you will see that the gradation goes from a value of say 700 or 800 kilowatt hour for the best possible filter that manufacturers have designed to almost double that value for a lower grade energy class filter. So those who are into energy efficiency will be able to take advantage of this. And they are always justifying what is the energy saving for the good things that they have used in their systems, and will be able to bring that out in a very good manner using these particular tools that have been designed. So what it does is it provides basically a kind of an ecosystem around the product, which is very necessary while going ahead to make the product tangible and explainable to the boardrooms and the building owners as to why these differentiated products have been selected and put into the design. And also going ahead, there is one point that comes to me time and time again, is when during such webinars or on interviews, we find people asking if offices will go with HEPA filters very soon. Offices are not designed for HEPA filters. The airside systems are not designed for that. And they do impose a lot of external static pressure, and changing systems to get into HEPA is going, if push comes to shove, then we'll all have to do it. But basically, that's not the first choice. First, stick to the HVAC filters. If you need to take care of PM1, take care of PM1 in certain critical spaces. And thereafter, basically, we can see if we have air cleaners or other things sitting over there, which can help in removing further small particles and take care of certain critical spaces that we are seeing and requiring today. Another good thing that you will hear about is that the famous blue line that I showed you in that graph, it can have certain variations. And I was very happy to see this ODA 1, ODA 2, and ODA 3, which probably Mark will go into in detail. And also uh, what kind of supply air levels, SUP1 to SUP5, we require in industrial spaces and in the other what we call the comfort world, or the hospitals and data centers, warehouses, etc., in order to achieve the indoor air quality levels that we are trying to achieve. And now the filters get nicely tied up with the outdoor air quality, indoor air quality, a tool to select the correct filter with the right pressure drops and have the right amount of energy being spent because of the pressure drop in the filters, and they reflect a different value going from I would say the everyday filter to the highest quality and the highest priced filter, uh, and it shows the energy efficiency difference. And that is going to be very helpful going ahead in keeping basically filtration levels and energy efficiency going together. So you will hear, and this document, as Marcus said, is available. Go through the detail. It's a very, very important document for HVAC engineers. Some of the service people would also be joining in, and they are used to this nomenclature, the F7, F8, F9s, and how would they go ahead with replacement of filters. This has also been provided in guide documents, and a lot of the other systems have also written about it. And you would not fall short of that as far as replacement filters are concerned. And I understand Mark is going to take this further into one-stage and two-stage filtration, and how you would put in your first stage and second stage. ECC, or Eurovent Certita certification, has come up with a very good program, ECP 11 FIL. It's kicked in 2020. We need to make it a success, basically, and it's very important that the filters deliver what they state, and that is what you get through certification. And you can be assured of the quality of filter that you are putting in your system. And then it's a job to measure the outdoor PM levels and the indoor PM levels, tweak things, do what is necessary, and get your indoor air quality levels right at the right energy spend. So filters go into all these areas. They go into shopping centers, they're going into high-end offices, they are going into healthcare, and of course they find their way into white rooms, the higher quality ones. Some of them tend to get into HEPA filters, but not all of them. And it's very important that we have a uniform standard going ahead, so that it makes the life of the designers simple, and we can deliver to the building owners what we promise them in our owner documents that we prepare. So a lot of guidance is available. Concluding my talk, the first and foremost point, the WHO findings brings out the importance of fine dust, and fine dust has been taken care of in this particular standard, ISO 16890, much more than probably a lot of the standards that I have gone through. And it does a lot of justice to it. ISO and WHO findings are based on PM1, PM2.5, and PM10. Environmental and IAQ standards globally. I've shown you the example of India. I have studied some of the standards which exist in neighboring countries, Middle East, and the parts of Europe. And I guess everyone refers to PM1, PM2.5, and PM10 these days. Get up in the morning, look at the newspaper, and it'll tell you what your yesterday's PM was. Go on to the net. Tomorrow, when we have a lot more of automation going on. Probably devices in the building will refer to the net and pick up the PM1, PM2.5, 10 that they expect tomorrow and take action in advance in order to reduce energy and have the right filtration to achieve the IAQ standard and assure the people who occupy the offices that all has been done by HVAC engineers that they could. I'm to say there's always that outside chance that upsets the apple cart, but before we have any provision for that, the HVAC engineers need to basically have done everything under the sun that they could do to have these occupants safe, whether in their offices, schools, or any place where people congregate. You can well understand that we all also let out particles which are either solid or sometimes partly liquid, and these are of very fine size, and they need, if we continue to do recirculation, which is a need from energy efficiency basis, we need to have the right part filtration in place going ahead to keep the occupants safe. Next point, filter nomenclature needs to be easy to understand by all involved in IAQ and airside HVAC. HVAC engineers or building specifiers have lots to go into, and they need one common simple specification or gradation and classification and standard going ahead so that we can deliver what we promise. With the addition of Eurovent guidebooks and recommendations, the program becomes more holistic and enables engineers to select the correct filters for maintaining desired IAQ levels, and with data on energy spent annually to achieve the required IAQ. You will hear a lot about these things going ahead from the experts, and that's my take on it. As Marcus said, we will be doing the panel discussion and taking your questions. We will do our best to answer all queries. My email ID is also given over here, and if you need to get in touch, you are most welcome, and we'll be there to help you all the way through in order to achieve IAQ standards and energy efficiency. And with that, I would like to thank all the 542 listeners and the panelists who are listening. And this was probably my first international foray. Thank you very much, Marcus, for having me on this program. Thank you.
Thank you, PK, for your presentation. I will get back to you in the end, of course, when we start the panel. We have already received a couple of questions. Thank you. For the moment, we move onwards to our next presentation. The guidance to the application of ISO 16890, and I would like to welcome Mark Schmidt on stage. Mark, please. And PK, please switch off your webcam. Yes, thank you.
Good morning to everybody. Good morning here from Germany. It's still a little bit early, 8:30 in the morning, and particular greetings to my AF colleagues all over the world. I heard that some of you are here dialed in. I'm the Vice President Technicalities of AF in Europe, and I'm the chairman of the Eurovent product group Air Filters, and I'm grateful for having that opportunity here talking to you. So thank you, Marcus, for the invitation, and thank you, PK, for setting the frame. I will go a little bit more into detail now. So I will talk, the core of my presentation will be about that Eurovent recommendation 4/23, which is about the selection of air filters according to the ISO 16890. Before we go into that, I will just give a short overview about how that testing is done. I know that most of you will not do that testing, but it might be important to understand what's the core of that testing. So that testing here to classify filters according to that norm, it's a multi-step procedure. You see here step 1 to step 6. And in the very first step, the filter efficiency between 0.3 and 10 micrometer particle size is measured on a clean, non-conditioned filter. So we get a filter, we measure the efficiency, then we have a curve. And the next step, what has to be done, that's step 2, is the filter will be conditioned. And conditioned means the filter will be discharged. Why is that necessary? Because there are filter media in the market which have a quite good filtration efficiency when they are new and unused. They are electrostatically charged, but with the time they are losing the charge. And then the efficiency will end up at a much lower level. To have a reasonable averaging of the efficiency over lifetime, so the efficiency of the new filter and the used filter, we are simulating here by the discharging what's happening over the lifetime with the filter. And how is the discharging done? It's done by putting the filter in an isopropanol vapor atmosphere, and this will eliminate the electrostatic forces. Then we are measuring again the efficiency between 0.3 and 10 micrometers now of the discharge filter, and that efficiency will be lower. In the next step, that's step 4, the efficiency of the new filter and the discharge filter is averaged. And that's an important point. It's averaged, and that's the efficiency of the filter. And the filter needs to show a minimum efficiency of 50% for the unconditioned and the conditioned filter for the respective filter class. I will come to that in a moment. When we have these average values, then the filter are allocated to one of these classes. So it's either an ISO coarse filter, an ISO EPM10, an ISO EPM 2.5, or an ISO EPM 1 filter. After that, the reporting value is defined, and that's the value you find on the label. The reporting value is the value for the filter is the highest possible ISO group with an efficiency of at least 50%, and that's always rounded down in 5% step. That sounds a little bit difficult, but it's quite easy. You see that here in the next slide. That's an example of such a classification. So we have a filter, and that was measured in a new state and in a discharge state, and we are measuring on the same filter an EPM10 efficiency of 89%, an EPM 2.5 efficiency of 63%, and an EPM 1 efficiency of 49%. So that's the same filter, and he has different efficiencies according to these particle size classes. And the minimum efficiency of 50% is achieved for the ISO EPM 10 class and the ISO EPM 2.5 class, because here we are over 50%. With 49%, the requirement for an ISO EPM 1 is not fulfilled. So the highest possible ISO group for that filter is ISO 2.5. So it has an efficiency of ISO 2.5, 33%. And that's rounded down in 5% steps to the next 5% value, 60%. As a result, that filter will be classified as an ISO EPM 2.5 60% filter, and that will be on the label. Let's go to the next slide. Here we see how that testing equipment looks like. That's our test channel in our lab in Slovakia. Here is the position of the test filter. In that chamber here, the test dust is generated. Here is the blower, and the blower is sucking the air here. Here are HEPA filters to have a defined air, sucking the air with defined particles through the filter and down here. And before and after the filter, the particle concentration is measured, and by that we can determine the efficiency. On the left-hand side, you see a discharge chamber. So that's a chamber where we are discharging the filters. The filter is hanging here, and here on the back side is a film of isopropanol is flowing down. It's a little bit heated, so we have vapor in that chamber. The chamber is then closed, and for 25 hours the filter is discharged and then is measured again. We come to that slide. That's showing a history and the dependence on the different filter standards. There is, I won't go too much into detail. That's something for the specialists. I'm missing here one arrow. Maybe that was lost in the transfer of that slides to the template. So the ISO 16890 is it's not a European norm, it's an international norm. I know that the HREF 52.2 is still widely used, and in other parts of the world, like in the States, even when the HREF guys there contributed to the setting up that standard, it's in the States the 52.2 is still widely used. The next slide is a comparison, is a rough comparison of the test procedures. I also will not go too much into detail here. It should be for your reference. You will get a copy of that presentation here from Eurovent for download, and that's for your reference. You see here the aerosols that are used, the aerosol size range, the aerosol range, the particle sizes, the loading dust, here the conditioning, for example, here in the EN 779, a flat sheet was discharged. There was already a discharging step, but a flat sheet was discharged, and here we are discharging the whole filter. So take that as your reference. That might be here a chart that's useful in daily life. It shows a correlation of the different filter classifications. As PK mentioned before, it's not possible to calculate from one filter classification to another filter classification. There is no formula for it, but it's a correlation based on experience. You see here, for example, in the EN 779, when we had an F7 filter that often was a MERV 13 filter according to HREF 52.2, and according our knowledge today, it's an EPM1 filter around 60% or an EPM2 filter of around 70%. So take that as a quick reference when you get a filter with a certain efficiency, that you know what ISO efficiency range that might be. So let's now come to a practical exercise, how to select a filter according to outdoor air quality categories and according to the desired supply air you want to have in the room. And the base of all of that is here, first is a classification of the outdoor air quality. So that's the air quality on site where the building is located. And there are 3 outdoor air qualities defined here. And the base for that is what the WHO guidelines recommend. We have here the cleanness level. For that, the annual mean for PM2.5 particles is below 10 microgram per per cubic meter, or for the PM2.5, and for the PM10 it's 20 microgram per cubic meter. Then when the outer air quality is worse, there's more dust in the air, these factors here are just multiplied by the factor 1.5. That's giving that here. And the worst outer air quality is then these factors here are multiplied by a value more than 1.5. So for such an environment, you see here that's a mega city with a lot of smoke. If normally there is an annual mean of 2.5, EPM 2.5, larger than 15 microgram per cubic meter, in that case an outdoor air quality 3 should be chosen. So that's the first step. Outdoor air quality is chosen according to the location of the building. On the next slide, we have to choose the desired supply air quality. Supply air, that's the air that's going into the building. And let's start here. Maybe let's start here with supply air quality 4. These are exactly the limit values of the WHO guideline, and we have here in the second column, these are rooms in the field of general ventilation. These are restrooms, storage rooms, stairways, and in industrial environment, the supply air here is for general production areas in automotive industry. For examples, these are applications without hygienic demands. When we go to a little bit cleaner supply air, the WHO guideline values are multiplied by a factor of 0.75. And here we have in general ventilation, shopping centers, washing rooms, server rooms, copier rooms, or in an industrial environment, that's food and beverage production with a basic hygienic demand. The next cleaner class here, then the WHO values are multiplied by a factor 0.5. Here we have kindergartens, offices, hotels, residential buildings, meeting rooms, exhibition halls, conference halls, theaters, concert halls. You see, these are rooms where a lot of people are coming together. And on the industrial side, that these are applications with medium hygienic demands, for example, food and beverage production. And the cleanest supply air quality here, the WHO guideline values are multiplied by a factor of 0.25. General ventilation, of course, should be or can be the same. In industrial field, we have here hospitals, pharmaceutical production, electronical, optical industry, and supply air to clean rooms. Just to mention, we also have defined here a supply air quality 5, where the WHO guideline values are multiplied by a factor more than 1.5. And these are rooms without occupation, garbage rooms, underground car parks, or in production areas in heavy industry like steel mills, smelters, and welding plants. So we have the outdoor air quality according to the location. Then we are choosing the desired supply air quality according to our application. And let's assume we are in such an environment. We have an outdoor air quality of 3. Let's keep that in mind. And let's assume we are designing or we are choosing a filter for a general ventilation application like a kindergarten, office, or hotel. So then we have supply air quality 2. How to choose a filter now? We have here the outdoor air quality. I've explained that. And we are assuming for our example here an outdoor air quality of 3. So we are anywhere in that line. And we want to have a supply air quality 2 So we are in that column. Shows here we have to use an EPM1 level filtration. EPM1 level filtration of 80% because we have auto air quality 3. We want to have a supply air quality 2, and we end up here at an EPM1 value of 80%. That's what the filter should bring. We have here two remarks for these higher supply air quality classes. The minimum filtration requirement is that in the final stage of the air filtration should be at least an EPM1 50% filter. I will explain that on the next slide. So we know now that for our example, we need an EPM1 80% filtration. How to get that? Auto air quality 3, supply air quality 2. I have one stage filtration. I take an EPM1 80% filter. That's quite easy. But what I can also do, in case of a multi-stage filtration, I can have an EPM1 60% filter, and in front of that an EPM1 50% filter, because when these filters are in a row, the final filtration is on an EPM1 80% level. How to calculate the efficiency of a multi-stage filtration system, that's also shown in the Eurovent guidance document. There's a formula in it. That's not rocket science. That's a quite easy thing. So if we have, for example, here auto air quality 2, and we want to have supply air quality 1 for pharmaceutical pre-filtration, then we have here EPM1 50% filter and an EPM1 60% filter. So I think that's pretty clear how to choose the filter, and that should be here specified. That should be specified. I need either a two-stage filtration with these efficient filters or a one-stage filtration, but then the filter has to have a higher efficiency here of EPM1 80%. Once again, the handouts, you can download them in the webinar in the webinar panel. Please use that. You also can get them from the Eurovent website, but download it from the panel here, and that's the document I just guided you through. And here you have some more detail and background information, particularly how to calculate also the efficiency of a multi-stage filter system. You see here my email address. If there should be any question, please feel free to contact me. You also find me on LinkedIn. Contact me for filter questions or any of my local colleagues. I thank you very much for your attention, and best regards from Germany.
Thank you, Mark. As you have mentioned, we have the guidance document Eurovent 423 available for download from the control panel. We have received a few comments that for some people they have issues with downloading. Please keep in mind we will provide all the attendees with an email after the webinar where you can find all the links for downloads to the YouTube channel, etc. So we will make sure that you will be provided with all the documents and all the access. Thank you again, Mark, and I would like to continue to our next speaker. Sylvain, if you could join me and start your presentation for certification of air filters. Hello, Sylvain.
Hello, thank you, Marcus. Thank you for inviting me to this event. So my name is Sylvain Courtet. I'm the technical director for Eurovent Certita certification, and I will talk about our certification program and especially the link with the energy efficiency for air filters. Okay, sorry, it's going in the wrong.
Well, let me help you
Yes,
here.
if you can go
So
through.
I will
Yes.
over to you again. One click at the presentation. Okay, I have a technical item here.
Okay.
My go-to panel does not really work well. Can you try now? Sylvain?
No, it doesn't seem to work. Can you click to the slides for me?
Yes, of course.
Okay, thank you. So I will start by explaining why certification is needed. Basically, the idea of certification is to level the playing field, is to allow to all, let's say, manufacturers to play with the same rule on the market and to provide a fair competition to the market. The idea is to provide a fair comparison using a standard benchmark, meaning standard testing methods and standard rating methods in order to increase the consumer confidence. This ensures that a performance before purchase. This eliminates, for example, oversizing due to underperforming uncertainty. It eliminates expensive customer verification tests. The tests are done under the certification scheme, and this avoids also excessive system operating costs. If you can go to the next slide, please. So in a nutshell, the certification aim is to build confidence. The objective is to de-risk all the process. It reduces the risk of inefficient and unsafe ventilation systems. It guarantees the energy efficiency of the complete system, and it avoids performance downgrade due to the use of non-certified spares during the maintenance. And all of this scheme is done under the ISO 17065 standard, which is a standard for certification bodies. And this is checked by an accreditation body, which is independent. And all of this scheme is recognized internationally through different international recognitions. Next slide, please. So first, we can see how Eurovent Certita certification has been dealing with ventilation systems and components during the past years. Eurovent Certita certification is working on ventilation for more than 20 years. As you can see, the first certification program was created in 1998 for air handling units for the complete system. And you see that over the years, different components in the HU have been introduced as dedicated certification programs, including air filters, which has been created, for which the program has been created in 2006. And the first certificates were available, I think, in 2007. So this was a key milestone in this journey. You see that we have dealt with heat exchangers, plate and rotary, runaround coils, ducts, and fans. And recently, we also added a program for hygienic handling units. And in 2020, we improved our energy efficiency rating for handling units, adding the efficiency in hot and humid climates. So from this slide, you can see that we have a complete holistic approach regarding certification of the ventilation system and all the components in the system. Next slide, please. So regarding the energy efficiency, the background is the Eurovent work on energy efficiency for air filters. Eurovent Association has been the first organization in the world to propose a method for rating the energy efficiency of air filters, and this has been done since 2013. So really, Eurovent Association was well in advance in the world in this area. Today, the latest document to describe how to rate the energy efficiency of an air filter is Eurovent 421, which is dated 2019, and explains how to compute the energy consumption, the assumed energy consumption of an air filter. And of course, this method can be used and is to be used together with ISO 16890, and I will explain later on how the connections can be done with the two documents. Next slide, please. So the principle is quite simple. An air filter is not, let's say, inducing directly an energy efficiency. It's a passive element, but it causes energy consumption due to its pressure drops all over its lifetime. So basically, the energy efficiency of an air filter can be computed based on its average pressure drop, which is shown here in this formula with delta P. And the energy efficiency, W, can be computed by assuming some basic values in terms of nominal airflows. Here you can see the standard airflow used is 3,400 cubic meter per hour. An average operation time, which here is assumed to be 6,000 hours per year, and an average fan efficiency, which is 0.5. From these assumptions, we can compute an energy efficiency based on the average pressure drop of an air filter. And the below formula shows the numerical application of this formula. The energy consumption kilowatt per annum is derived from the pressure drop in pascals. Next slide, please. So how should we rate the energy efficiency of an air filter? The testing method is as follows. You have to carry out first the ISO 16890-1 tests for a full-size air filter. Then you have to load the filter with AC fan dust according to the ISO standard 16890-3. It's the standard belonging to the same series as the -1. And this load has to be done until the amount of dust defined in this table has been reached. So for EPM1 filter, you have to load 200 grams. For PM 2.5, 250 grams, and PM10, 400 grams. Then from this load, you have to calculate the average pressure drop through all this process, and then you can calculate the yearly energy consumption, W. Next slide, please. So this is what I just explained is the principle described in the Eurovent Association document. Then from this value in kilowatt hour per annum, the Eurovent Certita certification reference document is defining in which energy class the filter has to go from this energy consumption in kilowatt hour per annum. What you can see here are the correspondence tables, where you can see that for EPM1 on the left, EPM10 on the upright, and EPM 2.5 on the below table, you can see from the efficiency, which is seen on the left side, you can compute the energy classes based on the result of the energy efficiency in kilowatt hour per annum. As PK explained earlier, you can see that, for example, for EPM1, the bad class is for air filters consuming less than 800 kilowatt hour per annum, whereas the lowest class corresponds to more than 2,000 kilowatt per annum. So it's more than the double difference between a very efficient filter and a not efficient filter. So this may have a big impact overall in the system if you take it into account. And what is very important here and to see on those tables is that the energy classes and the rules to define the energy classes are always based on first the filter efficiency class. So it means that not all filters can be rated the same way because EPM1 have a function of filtering very efficiently the air, whereas EPM10 have less efficiency. So it's very important to have different rules from those different type of filters in order to assess the energy efficiency. And here you can see on the right side the label which shows all the information related to this energy efficiency for an air filter. Next slide, please. So today we have more than 27 brands that are certified, representing more than 2,000 air filters certified. Filters that are certified are always at standard sizes, but it means that the one with other sizes can also be considered as certified. And from those 2,000 filters, you can see that there is a very few amount that reach A+. This means that the requirements to become an A+ filter in terms of energy efficiency is very high. Same for A and B. So these tables can show you what could be your, let's say, your target in terms of energy efficiency based on what the market can propose today. So if you look for a B-class filter, you know that you are looking for the top, let's say 25-30% of the air filters. If you are looking for A-class filter, it's around the top 12% of the air filters. So you can use this table to let's say define what is your requirement in terms of energy efficiency. And on the right side, you see an example for EPM1 filter, the distribution of the different air filters in terms of energy classes, A+ to E, and the filter efficiency from EPM1 50% to EPM1 90%. Next slide, please. So the conclusion is related to what has been discussed before, is that first you have to define your target filter efficiency. It's very important to not skip this this step. You shall not define first an energy or an energy consumption. The first purpose of an air filter is to remove dust from the air. So the first step is to target the filter efficiency. First the group EPM1, 2.5 and 10, and it was explained during the previous presentation how this can be achieved. And then you can define the value of the efficiency in percentage, again, as it was discussed before. Then the next step is to define what is your target energy efficiency class from A+ to E. And then you can find what are the relevant filters that could be interesting. And for this, you can use the Eurovent certification website by choosing the air filter that fits to your purpose in terms of filter efficiency and energy efficiency. Next slide, please. So thank you very much for listening to this presentation. You have here my email address, and of course you can send any question after this presentation if you have some. Thank you very much.
Thank you, Sylvain. And I will talk with you in a few minutes in the panel about that. We have received quite a lot of questions now. As the last point of the presentation part, I would like to call on Vanjaj to join me, please, for a summary of the key takeaways.
Thank you so much, Marcus. Hello, everyone. I am Vanshaj Kaur, and I'm the country representative for Eurovent Certita certification here in India. At the outset, I would like to take this opportunity to thank everyone who has taken time out to join us for this event. I would like to thank PK, Mark, Silva for the great presentations. Statistics also tell us that colleagues from over 60 countries have joined us. I thus thank the collective Eurovent team for helping us organize this event effectively. We have indeed learned a lot about the importance of ISO 16890 and how truly it is a global standard. Marcus, can you help me change the, yeah, thank you so much. Thank you so much. The new normal today is the indoors. Amidst the rising health concerns, all stakeholders for whom maintaining the quality we breathe. Marcus, can you help me shift the, thank you so much. Can you shift it again? Thank you so much. The new normal today is indoors, and amidst the rising health concerns, all stakeholders for whom maintaining the indoor air quality is important have lauded the ISO 16890 standards. Can you shift, Marcus, please? Thank you. Before we move on to the Q&A session, I would like to summarize and reiterate the points which my colleagues have made before me. Marcus, can you please change? Thank you. Understanding the filter nomenclature and the efficient tools on right sizing of the filters is very important. Can you shift again, Marcus? Again, energy efficiency and filter efficiency do not have to really contradict each other and should go hand in hand while choosing the right filter. ISO 16890 standards are there to empower in choosing the right filters. I would like to thank everybody who has taken out time to join us and highlight the fact that the Eurovent and REWA guidelines, as you see in the reference documents, would be readily available on our social media pages and will be mailed to you in addition to being there in the handouts. To end this, I would request Marcus to help us start with the Q&A session.
Thank you, Vanjaj.
Thank you, Marcus.
So let's move to the panel discussion, and I am happy to welcome Ilinka Nastase with us as a guest panelist from REWA. Ilinka, if you could join me. Hello.
Hello, Marcus. Thank you for inviting me to this webinar. I'm glad to be here with you today. I am the co-chair of the Technology and Research Committee of REWA, the European Federation of Heating, Ventilation and Air Conditioning. And I think that you might see that within the handouts that you have, you received some very interesting documents. These documents, first I would like to introduce the guidance, the COVID-19 guidance document in its revised form. It is the 4th edition, and REWA put a lot of effort in this document. And then you have a very interesting article from Professor Olli Seppänen regarding the criteria for room air cleaners choosing, which is also very important in this current pandemic context. And you have also a document that is presenting our COVID-19 online course, which is a training course with four modules. It's around 8 hours that you can attend via learning management system. It is interesting because you can, well, there are a couple of modules that are recorded, and the participants can watch at their own pace those modules and to complete exercises and examination. And of course, there is a certification of at the end of this training. And you have another document which is presenting the Riva Guidebook 11, intended to introduce the new global air filtration standard that it had been presented today a lot. And it's a very interesting guidebook regarding air filtration in HVAC systems that can be, of course, purchased at the Riva website. Yes, Marcus.
Thank you. As I mentioned in the beginning, so we have these handouts available for download through the control panel, as you have mentioned, obviously, Riva documents along with the Eurovent guidance. I would like to start with a question. As we know, there's an elephant in the room, which is the current ongoing pandemic. What is the correlation between indoor air quality and the infection risk in terms of viral particles in the air?
Well, now it's almost a cliche that we heard a lot. You know, that phrase that our colleague just told us 1 minute ago. We are spending 19% of our lives indoors, but it's so true. So it is obvious somehow that the indoor air quality is related to all problems that could influence our health state. And now this current pandemic showed, of course, that the air quality might be problematic. And there has been a lot of studies. There are some questions about this paradigm shift that we have to take in order to acquire more healthy indoor environments. The particulate matter exists around us in very high quantities. And viruses, all kinds of viruses can be attached to this particle and can be transported. One of the questions that we put ourselves is why the World Health Organization did not acknowledge, since the beginning of the pandemic, the airborne nature of this disease. But somehow there are some possible explanation regarding the statements of the World Health Organization. But now we know there are a lot of studies. Riva performed a lot of studies. We have some interesting tools that can correlate the indoor air quality and the infection risk. And it is acknowledged also that the concentration of CO2, for instance, in an occupied room can be a good indicator of the infection risk.
Thank you. I would like to call on PK. What role does recirculation play at the moment in this crisis, and what would you recommend in terms of air filtration stages in a recirculation unit?
So, 1 second. Recirculation is going to stay with us. I'm to say it's not going to change into a full fresh air system in a hurry. You know, if it really gets bad, then people might decide that we might have to go in for full fresh air systems. But if you look at international energy organizations and things like that, they're already raising that air conditioning consumes 35% of the world generated energy in order to keep us cooled or heated and things like that. So recirculation is going to stay. That's one thing. But recirculation done properly is different from just doing recirculation. If we all know that we shed particles, so even if you close the place up and somehow manage to add oxygen into the atmosphere, into the rooms, we would still have particles which need to be taken out. And in order to do it in an energy efficient way, we will need filters. And it's better to get down to the lowest level with the normal HVAC filters, and then between REVA, us, and all the world agencies, we can sort of experiment and find out how we can achieve it in an energy efficient way. So it's 1 and 2. First, do your basic job right, and then come out and do the experiments that are required to take out the harmful particles. Particles are always going to stay around. That's my take on it. Thank you, Marcus. Back to you.
Okay. When we look at the realistic situations in the region, and I believe might perhaps also be the case in India, a lot of maintenance crews used to take out air filters from air handling units and wash them and put them back in. Maybe Mark, you could shed a light on this practice and let us know. So, what is recommended from the industry in terms of filter replacement? Should filter be washed and put back in service, or should that totally go out of the system?
We do not recommend to wash filters. Filters are built up of very fine fibers, and when the filters are getting wet and maybe mechanically stressed during a washing process with high pressure water, that structure will change. So such filters will definitely drop in efficiency. We do not recommend to do that. Of course, if it's still the last thing that could be done before running an HVAC system without a filter, that goes without saying, but we do not recommend to do that. Filters for HVAC systems, filters for dust removal control in technical processes, that's a different thing. I'm talking about filters in HVAC systems.
And what is usually the life span of an air filter in a situation where you have an outdoor air quality of level 3?
Yeah, the classical answer is that it depends. But when we are talking about experience, a normal lifetime we see in the field is normally between 6 months and a year. So when such a system is designed, normally a lifetime of the final filter stage is maybe 1 year, but the pre-filter stage, which is normally a panel filter of lower efficiency, that can go down even to 3 months or 6 months.
Thank you. Then Sylvain, if you could join me. Certification. I think there is still a little bit unclarity around certifying air filters. In which way are they certified and checked? Do you check every single and every individual filter, or is that related to the filter material?
Okay, thank you. So for this certification program, all filters that are certified shall be, let's say, controlled by an independent test or a test with a test report, which is provided by the manufacturer. But then afterward, we are doing a random selection of air filters every year, where those filters are tested in one of the 3 independent laboratories that we are using. And this is done on an annual basis. So there is basically a 2-step approach. First, the manufacturer has to do the job and provide a test report, but then it is checked again independently by laboratories that are accredited according to ISO standard, that are let's say the key laboratories in Europe to work on air filters. And we do that on a random basis. We select filters on site in the factories or in the stock locations, and we send them to the independent labs. So really it's a very strong process, and an independent process that we use in order to assess the performance of the air filters.
Thank you. When we look, Shivan, when we look at the past years, we have seen a global push for more energy efficiency, decarbonization, and indoor air quality has been a little bit left aside. So the focus of governments and the industry has mostly been on energy efficiency rather than indoor air quality. How does the Eurovent certification program in this case help to mediate the balance between energy consumption and indoor air quality?
Yes, thank you. As I tried to explain in my presentation, the first thing to do is to check what are your requirements in terms of indoor air quality. So for air filter, it's the filter efficiency, and we do certify those performances. Afterward, in each of our program, including air filters, we also check the energy efficiency, and you can also verify how the products you want to install is and is rated among others, and this is done with the same rules, the same testing methods. So it's really a very good benchmark, which is done independently. So on indoor air quality and on energy efficiency, you can let's say assess what are your requirements, and we do provide the related performances that could fit to your needs. Thank you.
Vantaj, what kind of regulatory developments can we observe on this subject on indoor air quality? What is happening in India, for example?
Thanks for the question, Marcus. Especially in India's context, over the past couple of years, it has been pertinent that the situation of ambient and indoor air quality need to be approached very systematically. To this effect, the government of India has come out with the National Clean Air Program in the January of 2019 under the Ministry of Environment. In terms of fetching the real-time data, they are using existing programs called NAMP and NAQS. And in terms of execution of the standards and the targets that have been set for the IAQ and the ambient air standards, there are a couple of ministries that have been targeted in achieving those standards. But I would really agree to what you just mentioned, that even though there is a policy document that has come out, the focus largely still remains on the outdoor air quality and the emissions. And IAQ, even though it is important and is recognized by the government, it is not really highly highlighted in the policy document itself. So I mean, there is a policy document, but there is a need to sensitize the right stakeholders to raise more awareness about IAQ matters also.
Thank you, Vantaj. Ilinka, if you could shed a light on the European developments on that matter.
Marcus, can you hear me? Yes, of course, there have been ambitious goals of reducing energy consumption in EU since a long time ago, but now there are more and more ambitions, and this is reflected by the energy performance of buildings directive recast, and this includes measures that will accelerate the rate of building renovation, and this is very interesting from this point of view, because we want to achieve more energy efficiency systems. And here comes the point of apparently conflicting requirements in terms of indoor air quality and energy performance of HVAC systems, but it shouldn't be that way. The EPBD states clearly that the indoor environment quality should not be reduced because of improved energy performance. We have to find systems and upgrades of systems that will contribute to a healthy indoor environment and stick to this goal of energy performance. And here I think that a good practice example is the Eurovent recommendation for 21 from 2018 with energy efficiency evaluation of air filters, and this new standard that makes much more easier for designers and facility management specialists to choose the right filtration solution.
Thank you. Mark, if you could give us a bit of an estimation, what do you think we will see in the years ahead in terms of regulations on indoor air quality, and also in the way countries, governments, industry will approach this topic to protect us in the future against further viral diseases?
The pandemic will stay with us, I think, for a certain time. That's nothing that will be gone in a few months. And with that, the awareness of good air quality will increase and will stay, and that will be reflected in regulations. Good air quality won't be a nice to have, as it's sometimes seen. It will be mandatory. As a very concrete step, I expect that the recirculation units in HVAC systems, they will have mandatory air filters, and I also expect, at least here in Europe, that the filter classes will go up. They will go up, and the EPM1 filters we see in the market, EPM1 60% filters, for example, that will be a standard for HVAC systems. In places where we today see very often still EPM 2.5 filters.
Thank you. PK, you have mentioned in your presentation that replacing normal air filters with HEPA filters in office environments makes no sense. If you also take a look in the next future, in the coming years, do you believe there will be a bigger push for developers to implement HEPA systems in normal buildings?
My answer would be no. Basically, HEPA filters, maintenance, cost, everything is kind of prohibitive. First, do your normal HVAC filters right, go up to EPM1, high efficiency, and then if there is still a doubt, you have the air cleaners. Don't just put an air cleaner in a place where you've got everything circulating around you and expect it to do wonders. So it's going to be a 1 and 2 kind of thing. I don't see HEPA filters. I wouldn't want people to talk about HEPA filters in normal office air conditioning till they have exhausted everything, and till the standard air cleaner lying next to people who are vulnerable also is an issue. That should be our next goal. That's my take on it. Can I just take a minute more? Can I just take a minute more? Because we are coming to the end. I would really like to thank you, Marcus and Eric Foucault, for allowing India to participate in this discussion today. This has been a first of its kind. And I think going forward, looking at national policies and how we amalgamate ourselves with the rest of the world, because at the end of the day, it's one world. Air in India will affect air elsewhere. People from here will travel elsewhere, and we need to make it a big world. And you've gone a long way in helping us achieve that. So I just wanted to thank you on that. Thank you, Marcus. Thank you, Eric.
Well, thank you, PK. And I would like to come to a few more questions. So we have received further questions regarding the washability of air filters. Mark, if you could maybe renew this stand that it is actually absolutely not recommended to wash the general filters, right?
Yes, there is no doubt about it. When you wash the filters, then you will destroy the structure of the filter and the efficiency will drop. There is absolutely no doubt about it. If by any accident, by a sandstorm, anything like that, a pre-filter might be clogged and it's absolutely necessary to do anything to clean, then shake the filter, take a little bit low pressure air to blow the surface clean, but washing your filter will destroy the filter. You might not see that, but that can be measured.
Thank you. Let me see another question. In general, what are filter classes that can separate bacteria, virus, fungus, etc., so biocontamination? Ilinka, if you could help me answer this question. Are EPM1 filters with an efficiency of 80% sufficient to filter out biocontaminants?
Well, it depends on the environment and on the concentration of particles that are susceptible to be carrier of airborne viruses. The fact is, we know now that those viruses are not traveling by themselves; they are traveling by particles that might be resulting from the dehydration of saliva and other droplets generated by the human activity and presence. So it depends also the risk, the possibility of risk and infection. It depends, of course, on the density of people and of the their activity level. And I would say that that it depends. Of course, if the environment is problematic, like in hospitals or other rooms that are special, I would say that is not enough. PM1 is not enough.
Mark, I see you want to comment on that.
Yes, Ilinka is absolutely right. The viruses normally do not travel alone. We see the particle range between 0.3 micrometer and 1 micrometer is particularly critical, as these particle sizes are normally carriers of viruses. And the simple answer is put in the best filter you get. The best filter you get is a HEPA filter, knowing that's not possible to retrofit every HVAC system with a HEPA filter. But an EPM1 80% filter, for example, still has a relatively good efficiency in that range. And if there is a recirculation in the room, raise the recirculation rate as often the air is going through such a filter, as faster the particle, and with that the virus concentration is going down.
Thank you.
So not only a high efficiency filter, also raising the recirculation rate.
Thanks. PK, I would have a question to you. One of our listeners is asking if the ASHRAE 52.2 standard is now obsolete in light of ISO 16890. And another question comes surrounding this ASHRAE standard. How can we make sure that the ASHRAE filter standards are on par with ISO 16890? Since in many areas this standard is still applied.
So I wouldn't say that ASHRAE 52 standard is obsolete or so, because their working groups are talking to each other. You know, when you take the ASHRAE indoor air quality group, ASHRAE 62, and the air filters group, they are in dialogue with each other. They also understand this problem, and they are probably going to come out with something new, of all you know. So I wouldn't call it obsolete. Of course, they would want to hold on to the name that they have set up across their country over a long time, and take corrective action, and look objectively at ISO 16890. I'm saying it's time that more and more countries are signatories to ISO 16890, or sorry, to ISO standards. And US by itself is also moving into ISO standards wherever those are the only standards available. I've seen US documents where ISO standards are referred to. And I wouldn't say that 52 is obsolete. They are modifying, they are working on it, and probably you will see some changes in that as well. The gradation and the preparation of filters and all will be incorporated by them also. Thank you. That's my take, Marcus.
Thank you, Mark.
Let me add one thing. I don't think that the standard is in reality obsolete. The original intention of the ISO 16990 was to have a global standard. And the Europeans with the EN 779 and also Americans colleagues coming from the ESHRE world, they worked together and contributed to that standard. So it's an ISO standard, it's a global standard. Nevertheless, the adaptation to that standard has a different pace in a different region of the world. We here in Europe adopted the standard relatively fast. Sometimes our customers and maybe even we internally in the company are still talking in F7, F9 classes just because the word is shorter. But in business life, we are living in Europe, the standard. When I come to the States, and I mean, I work for American Air Filters, I have a lot of American colleagues, they still find it a little bit hard to live in the ISO world, but I see a slow adoption as well. So in daily life, the ESHRE standard, coming back to your question, is not obsolete, but I mean, there is a reason why an ISO and a global standard was set up.
Okay, thank you very much. We are already over our time. I would like to make us a quick last feedback round among all the speakers. First of all, if you want to drop a final comment from your side, please feel free to do so. Otherwise, I would like to hear from you this comment, one comment on harmonization. Why is it so interesting and so important that we have a harmonized standard on air filtration? PK, if you could start, please.
So, as you know, the HVAC designers and consulting fraternity has a lot on its plate, you know, and added to that is today the complexity of indoor air quality, energy efficiency, chiller standards, change in chill water piping techniques, unitary VRVs making inroads into areas that were traditionally controlled by chill water systems. Even today, chill water systems see far more specifications than what VRVs see. So when it comes to filters, it should be definitive and it should be the same across all the different kinds of systems that we use. We cannot have basically what you would have thin pieces of strips of things with almost 10, 15, 20 pascals pressure drop and saying that this does the job, it does ionization, it does polarization, and then compare it with chill water systems where we put in these heavy pressure drop filters in order to maintain spaces and have to equate one against the other. It doesn't work. So harmonization is very, very important. If you want VRV, VRF to compete with chill water systems, have at least the same filters put in the airside units that are attached to VRV, VRF units, and then compare apple to apple. That's my take on it.
Thank you.
Thank you.
Sylvain.
Yes, yeah, maybe the most important thing is, as what was mentioned, is now we have a global standard, and it's a chance. It's based on really meaningful value. EPM 1, 2.5, and 10 were discussed a long time ago. So really, this standard is really relevant and useful for day-to-day basis. And now we have tools, we have documents, we have certification to provide a very useful data for everybody looking at both indoor air quality and energy efficiency.
Thank you. Ilinka?
We are talking so much in Europe about renovation wave, Green Deal, all the recommendation that the European Commission gives us, HVAC, the building services engineering in general, mechanical engineering, I would say. So it's important now to have, like Sylvain said, meaningful values for both for everybody, for the designers, for the those that are making the execution, and for everybody. It's important to have this global common language regarding testing methods, the possibility to select air filtration efficiency as a function of the outdoor air quality, for instance, and the required supplied air quality. It's important to have meaningful values, I would say.
Thank you. Mark?
Yeah, we are living in a global world. Yeah? There's a building built anywhere in Dubai or in India or in Kuala Lumpur. There's maybe a local consultant, but the construction company is coming from the States and they're ordering an air handling unit from a different country, and in that air handling unit is a filter from the next country. To make sure that the whole system is working together in the way it's designed and it's intended for, it's important that all people involved are speaking the same language. And in that sense, a global standard is the same language. And that's what I see as an advantage of a global standard. To ensure comparability, that's one thing, clear, but also to ensure the proper functionality of the whole system.
Thank you, Mark. And Vanchaj, last comment from your side?
Thanks, Marcus. I would totally agree with Mark and Elenika. The fact that we are living in a global world, we have to learn from each other. And especially when it comes to what PK just said about harmonization in terms of the Indian context, the Indian ecosystem has done pretty well in raising awareness about the PM levels in which we live. But we do have to work a lot on the IAQ matters in like Elenika put it, in relation to the outdoor air quality. It has to be a function of the outdoor air quality and the energy efficiency also. So I would say that we are living in a global world, and we should have more events like this where we can exchange views and learn from each other and get to learn from people who attend these events. On that note, I would like to highlight to everybody who is present that this is a part of a series of events that Eurovent Certita certification and Eurovent have been doing for the past 3-4 months now. We organize such events every month for the benefit of all the stakeholders, sharing our knowledge with you guys. If you have any suggestions as to the topics that you would like us to cover when it comes to the HVAC industry, we would love to have your feedback on our social media pages on LinkedIn or our email IDs also. And we will be having another session in a short time in the next month perhaps, and we'd love to have you guys back again with us.
Thank you, Vanjit. Right, so we are coming to the end of this webinar. I would like again to alert you that we will provide you with an email within 24 hours of this webinar, which will contain links to our websites where you can download the presentations from today. The webinar recordings will also be available on the Eurovent and Eurovent Middle East YouTube channels. Please just go to YouTube and look for us. You will find us there. Please subscribe to our channels. You will then get the notification once the recordings are edited and finalized and uploaded there. We also would like to encourage you to follow us on LinkedIn in order to be aware of our future events. We always announce all of our conferences and webinars through emails and also on our social media channels. I would like to thank again our knowledge partners of today, REWA, ISHRE Institute of Excellence, and the ISHRE Daily Chapter for your support and your expertise. Thank you again also to Climate Control Middle East, our media partner. Thanks to our speakers. I hope you have enjoyed it. I hope the webinar was of interest to you. And thanks to all of you joining us today. I hope we can see you soon again at one of our next webinars. Thank you very much. Have a good day and stay safe.